For everybody who's on the remote, we'll be getting started in about 2 more minutes when the coffee shows up for me and my co-chair to keep us going. Come on. Dirk. Oh, still waiting. What's going on? Oh, there he is. Oh, all right. The important things have happened, so we can get started. Oh dear. Somehow the window that has your login disappeared. So you're still active.
Yeah.
So I'm trying to find your Meet Echo window.
Oh, right. It has disappeared indeed.
Yeah. And mine just died.
Okay, let's do this again.
It's interesting. You're still shown as being in the meeting.
Yeah, fantastic.
And you're still shown as sharing the chair slides. Oh, there you go. So, shall we get started?
There are actually a few people still in the coffee line.
Oh.
But let's just do that.
So again, for the remote people, there's no camera on the coffee line outside, which is why we're waiting for that queue to clear, because there are more people who want to come in the room who are still on the coffee line.
There's one.
Here comes one. So just give us another 2-3 minutes. Sorry for the delay. server unreachable.
You know, we all know research runs on coffee. That's fine.
What?
We all know research runs on coffee. The delay is fine.
Yes. So,
Oh, I lost my Wi-Fi.
yeah, same here. I think this corner is not very well covered.
All right, now I'm on V6 only, which should work okay. Nope. Try again. Did you lose as well?
This time.
All right, try going back to IETF again. Okay, now try. Nope. Let's come back here. Come back here.
Yeah, let's start.
Hmm?
Should we start?
Yeah, all right, let's get started.
Okay, I think there will be some interest timeout for the remaining people still in the coffee queue. Good morning. This is IC Energy. Thanks for coming to the meeting, and also good morning, everybody online. This is my co-chair, Dave Oran. I'm the co-chair, and great to see you all again after some really, really hard years. And I think this is the first meeting where we have two co-chairs present for a really long time. Okay. So just usual housekeeping. Please be aware of the IPR disclosure rules. So in general, you have to inform us in case you contribute or see any IPR contributed that is relevant to the work and discussions here. Okay, so yeah, I hope everybody is signed in using the QR code or just the agenda links. Of course, this is recorded, so please be aware of that. And yeah, so again, we are not doing standards here. We are primarily interested in doing continuous research that helps the evolution of the internet. So, and check out the IETF primer for IETF participants if you want to learn more about this. And the most important thing before we get started is that we really need a note taker. So we can't really run the meeting without having one. And so we really need your help, and we are looking for a volunteer. And yeah, note taking is not a very hard job. It's not about capturing everything that is said, just capturing the gist of the discussion. That's what we need.
We put out a plea yesterday, but nobody answered. So I'm sorry we're taking up time now on something that could have been handled in advance.
I have just kind of started the sort of template, I guess. So I'm gonna do my best, but I would very much like support from others because my typing is not the fastest.
Okay, thank you very much.
Sorry, Ryo Yanagida from University of Glasgow.
Great. If you even get sort of like the gist of things, this is the sort of thing can be fixed up afterwards.
Yeah.
I'll try my best.
Thank you. That's very helpful.
And in order to facilitate that, yeah, please mention your name when you say something. May make it easier for the note taker. Great. So with that, quick look at the agenda. So we will have an update on Flick. So Mark is participating remotely.
I do not see them online.
And we have an update on reflexive forwarding. We have Colin Jennings talking about the media over quick work. Cedric talking about adaptive media streaming work in ICN. And we have Ueda-san talking about loss detection for ICN. And we have a couple of things to share with you and discuss with you at the end. So that's the plan for today. Any additions or any change requests? Good. Quick update. So first of all, clap your hands for RFC 9344, CCN info, published a few weeks ago. So after really good work, good discussion here in the group. So yeah, CCN info, if you're not familiar, is a tool that allows you to find out more about the capabilities of an ICN network. So it's one of the important tooling elements that we need for experiments and working with the networks. Then we have a couple of things that are going on. So the CSNX time TLV edition is still in ISG review. So Flick we are going to hear about in a bit. And ICN ping and ICN traceroute, they finished ISG review actually. But we wanted to publish them because they're relying on path steering and wanted to publish this as a package. And so this is currently waiting on me writing the Shepherd summary for path steering. So that's happening next. So path steering, as you remember, finished ICNRG last call recently. And so now this is the next one that we want to hand over to the IRSG. All right. So, do we have Mark already?
He's not on the meet echo.
Okay.
I just sent him a text and an email. So
Do we want to do forwarding first?
yeah, I'll do it forwarding first.
Okay.
You can keep bugging, see if you can get a hold of Mark.
Okay. Okay.
Can you share my slides?
I will. Yeah.
Thanks. Okay, so this is going to be a very quick update. There's a new version of the draft that got uploaded just a couple of days ago. So this will sort of try to bring everybody up to date. Next slide. So let me remind people what this is about, which is that the sort of like the canonical ICN protocols that we've had for 10 plus years are a two-way handshake request response style of interaction.
Dave, is this mic actually on?
Is it on now?
Yes.
Oh, very sorry. I talk loud, so maybe you could even hear me. So many of the scenarios that we use, this two-way request response, very simple machinery, work great. But there are a lot of scenarios that we know from many years of trying to build distributed systems that two-way handshakes don't cut it. You need multi-way handshakes. So this is true for RESTful communication on the web. It's true for RPC and other forms of remote method invocation. It's true for kind of phone home situations where you need to provoke a response from somebody, but that is intended essentially to get you to do something. And pure state synchronization is by definition can't be done with fewer than 3 handshakes and in some cases 5. So we thought, what would one do in a clean way to extend the two-way handshakes that are popular in the existing ICN protocols without upsetting the whole apple cart. So the features we really wanted to be able to do is take a poll-based architecture like our existing ICN protocols and make them really convenient for pushing data without switching to a completely different protocol scheme that pushes data directly. And to allow for session continuation, which is needed both for efficiency, security, and ease of application development reasons for where we have things like RESTful communications. So we wanted to be able to do all these things without upsetting the apple cart of our existing protocols. Next slide. So very quick design overview, just so you refill your cache of state. We utilize the forwarder state that's established on the forward path when you send an interest message toward a producer. And you allow those breadcrumbs to be used to return a request back to the originating consumer. So we have a forwarder mechanism for routing things back to the consumer from the producer, and a way to couple the state of the original interest data exchange to what we're calling the reflexive exchange, which is the one provoked back from the consumer to the producer with this protocol. So we have the design justifications in the document, and we have the protocol mechanisms. Next slide. So here's our current status. It's still an individual draft by your two co-chairs, which is kind of a little weird since we really prefer to see technical contributions from the participants rather than just the chairs. We've addressed a whole bunch of comments. Now, some of those never appeared on the list just because they sort of started as a background conversation among us and a very careful reader of the document, Hitoshi Aseda, who's online, and hi, Hitoshi. And we've addressed all those comments, plus some hangover comments from Ken Calvert from the previous version, and spun those all into version 5. If you want to look at the actual way we've conversed about the issues and how they were resolved, we have a GitHub repository with the issues documented there, and you can go look that up if you want. Next slide. So here are the changes, not microscopically, but just in general. We had a fairly substantial terminology problem that caused new readers and even repeat readers to sort of like get their heads wrapped around the axle, two things that were very similar but not exactly the same and didn't have exactly all the right wording. So we fixed the confusion about the way things are named, what we call reflexive names, and fields in packets that refer to those names, and added at the beginning of the formal specification a terminology section that actually defines these things rigorously. We had some labeling problems and some real confusion in the protocol ladder diagram we had to sort of visualize the protocol exchanges, and we fixed all that up. And I got some very nice early feedback from IANA. It's really nice that they start looking at things so early, which pointed out that we said we wanted to register things in a registry that actually that they didn't think existed because we had misnamed the registry. So that's all been fixed. And then there's a bunch of small editing changes for clarity. Next slide. So next steps. We have gotten some significant interest from NICT in Japan to actually build an implementation of this based on their C4 CCNX implementation. It would be very nice if we could get somebody in the NDN community to do an implementation for NDN as well. And given that we're starting to see this kind of interest in implementing it and using it for building more a wider range of applications than we've seen over ICN in the past, is it appropriate at this point to actually adopt it as an RG work item to forward the research in this area? So we're going to be asking those kinds of questions on the list following the meeting. And please read and comment on the draft. Please weigh in on whether you think this is the kind of research work that would be helpful and maybe quite valuable in advancing the scope of use of ICN protocols for building applications. So thank you.
Thanks, Dave. Any question?
Anybody in the queue online?
No.
Going once, going twice. Thank you.
Okay. So unless /U5218 is Mark Moscow, then I think we don't have Mark in the meeting at the moment. Then let's say, Colin, are you ready? Okay.
I did not get an answer from either the email or text.
Good morning, I'm Colin Jennings. I'm going to be talking about some work that we've been doing that is related to this and this quicker work. Now, a bunch of what I'm going to sort of talk about today is sort of naive in many ways compared to, you know, a lot of the stuff this group's doing, and I feel like I'm sort of, you know, scared presenting it. But I think that it highlights a bunch of use cases that I want to talk about, and I think that we have a lot of focus on deployability, which is, I think, one of the difficult topics in this area is we have a bunch of these great ideas, and how do we get them in a state where they get used more broadly. And I think there's a bunch of things that are sort of changing that are going on with AR and VR and sort of the requirements around that. And I'm going to talk a little bit about those problems more. So this, you know, take what I'm going to talk to you about today as more me talking about problems and ways that we might use those problems that are happening broadly right now to focus in how we might make these systems such that they can get deployed in a broader set. And I'm less focused on the details of our particular implementation or in any of those things, because I think, frankly, that they're simple things that we're trying and explain in simple ways so we can get closer to moving to some of the more advanced things that have been thought about. So next slide, please. So the first thing I want to talk a little bit about is some of the media types that are happening in AR and VR these days, and a little bit what they're driving, and then I'm going to talk a little bit more about some of the other requirements that are happening a lot in broadly right now that I think that this work can be a really good solution to, and I'm sure everyone will see sort of how that connects together. So next slide. And I should say overall in this presentation too, there's lots of time for some discussion. Stop me anywhere we want along the way. I'd like to have discussion about it. So the context of where I'm coming from on this is some other people in the room, Suhas and Will and others and I have been working on a AR, VR, 3D holographic collaboration system. And it's called WebEx Hologram. I'm not really talking about the product, but I'm going to talk about some of the requirements and things came out of it. And it allows you to, and there's other people working on systems like this, it allows you to use an array of cameras and capture a light field of a person who's presenting and perhaps some object that they're showing. And then for somebody on the far side to see that as a live, real-time, photorealistic rendering of the hologram, you know, if they're wearing a headset, of a hologram sitting in front of them of that person presenting the 3D object. And it's not just like stereo. If you really move your head from one side to the other side, you see different sides of the object. It is a 3D object. So next slide. This is driven to a bunch of different techniques. Of oh, thank you very much. Awesome. Even better. Okay, I'll see if I can figure out how to use it. So this is really driven a bunch of sort of variations of the media types. So part of what we're seeing is not just the traditional audio and video sent over the internet, but we're also seeing a lot more of people trying to send, you know, textured map polygons. So this has often been where these systems started. It's widely used in the games. There's lots of infrastructure to understand and deal with these. It has a lot of noise problems when you capture in real time. It often has bad visual artifacts. So a lot of people have moved away from these techniques, but they're still used for some of the objects some of the time. And then the next approach that we see a lot of is these point clouds. So there's media that instead of looking like a bunch of polygons and texture maps, we're seeing much more of a large collection of points that each have a color associated with them. And when you render them at a high enough density, you get the effect of a visual artifact. So this is a point cloud capture of the shoe. And it's better at representing fine detail, and there's less susceptible to noise is one of the primary driving factors that people use them. But there's a couple different ones there. Our system, we're using light fields where we're trying to, the light field is an idea of having an understanding of what the color of light, or an approximation of what the color of light going through every point in this room is from every different angle, and then from that field, you can render any viewpoint you want. And you know, there's a lot of growing techniques that move all of these along, but they all have sort of different media characteristics of what you want to do and what you bring into these systems, and different object sizes, different ways dependencies work between those things, that makes them sort of fit better into this named data networking model in some ways than just streamed data traditionally did, because they don't necessarily divide up into a stream in the order you deliver them in and how you deliver them. So there's also just things that is, you know, like a lot of these systems allow you to use your hands to grab something and manipulate things, or you can grab things with a pointer and move them around. You're making 3D interactions in a way that was much more solid or realizable than the traditional 2D collaboration conferencing systems. And so there's just things like, you know, how to encode all the joints in your hand and render a hand on the far side and be able to use that to detect a grab. Like that type of data is flowing around in these systems a lot. So that's the type of data that we're sort of seeing of these media objects. And there's a fair, you know, there's a lot of large companies working on various forms of doing this. There's a lot of academic research onto this area. I mean, there's a huge amount of interest in sort of trying to figure out all these techniques, how they fit together, and what the advantages are. So I'm going to shift to talking a little bit about latency and some of those things. So the system that we're running today is very much just, we have an array of cameras at one end that captures our light field. That's on side one. We're feeding this up to, you know, a classic cloud, AWS in this case. We're doing a bunch of processing of the light field. It's about a 30 megabit per second uplink stream. And then we're feeding the data down to each individual headset. That's a partially, you know, just, it's not the full light field. It's about 6 megabits per second, and it's a reduced set of information that allows the headset to have enough information to be able to really rapidly render a new scene. So when you spin your head like this, there's not enough time to go back up to the cloud and get information, come back down or anything. Like, you have to be able to do local small moves of the headset. But the cloud is aware of where the headset generally is and as it's moving, and it's sending the information that it would need. You know, if I move 3 feet to the right, I can't render that view without getting that new information from the cloud, but I'm unlikely to do that in less than 100 milliseconds. So in the round trip times back up to the cloud and down again, I can get all the information to keep the viewpoints that I'm likely to be able to move into in the near future. So this brings up the, you know, we've had lots of discussions about how do we move things out closer to the edge. How do we get that compute that we're currently doing in the cloud and move it down to sort of local compute? And whether that's like a 5G type local compute model or some other one doesn't really matter. And I think that a lot of the techniques that we're looking for here is, how do you discover that compute? How do you connect up to it? How do you get the information that it's producing? How do you dynamically sort of like allow a service to scale from only having an AWS cloud to moving into having these types of things? And again, I think the techniques that we're talking about here help with those types of issues. So that's one of the areas I think that this helps with deployment, but we need to bring those actors and the people who can deploy in those places into the conversation. And I hope you guys keep an eye on the queue and tell me if okay. So another direction that things are going is scaling up the size of meetings. So today, the major web conferencing sort of products and that I sort of work in, you know, support meetings with orders of 100 people, right? And, you know, 200 to 500 here, and who knows, maybe one of those numbers, you know, maybe last week one of those announced on a larger number. I don't know, but we're in that range of zeros. And no one wants to be in that range of zeros. People want to move to be able to have a company-wide meeting with 100,000 people on the same meeting. So there's a real idea, and these numbers have been creeping up from, you know, 20 to 50 to 100 to 200 over the past 7 years. Really, they're moving up in the way you might expect. But these systems are looking to have a very dramatic increase in the amount of scale and what they can be used for them. Part of that was just the last few years of COVID sort of made people more accepting to use these in much broader cases than they had in the past. So all of these application developers are trying to figure out what are the technologies they could use that could give them this huge increase in scalability. At the same time, there's huge amounts of live streaming today. I mean, when we look at Twitch, YouTube, all of these types of things, there's a very dramatic amount of that being used. it's obviously hard to get revenue estimates in this type of area that are really concrete. But for a while, it was before Twitch was acquired, they were publishing the revenue data and the amount of type of stuff they're doing, and we're talking about billions of dollars here on all of these. So it's not small that way. It's not small from the sort of amount of traffic on the internet, and I think that again is the changing desires of these types of applications are one of the things that can help this type of technology deploy. So the point I want to make about this slide is that with live streaming, things like HLS- solve a problem where you're willing to accept a latency. Let me say in the 15-second zone. We can argue what that latency is. Maybe it's 5 seconds or whatever, but sort of in the longer zone. But if you can move that down a lot, you can have a more interactive experience with the audience that you're streaming to. And the applications that have chosen to have that type of high interactivity with the people they're streaming to, so somebody can comment on the stream and comment on the stream in a pretty real-time sense, not comment on the stream on what it was 15 seconds ago. Those types of applications are doing quite well in the market, and I think that the people are seeing a shift of wanting to move that direction a little bit more. So the live streaming people are looking at trying to reduce stuff. And look, these slides were originally done for the mock working group. Really, this is part of the argument there. But I think that the types of techniques here can help with that a lot. So the live streaming wants to lower their latency. The real-time collaboration people that have fairly decent latency want to increase their scalability. And that, again, came to, I think the techniques here can be a big portion of that. And some of the stuff we're doing in mock sort of fits into that. So that's sort of some things that I think are changing on the desire of what people are building on the internet that makes it easier to be, if we have a good solution to that type of space, get it more broadly deployed. So this brings us down to, well, what do we need to meet those needs? And you talk to different people about this. You can see it as a name data networking problem, an ICM problem, all these things. You can see it as an overlay multicast problem. You can see it as a pub sub problem, which is the metaphor we've used for application developers. You can see it as a message bus problem. The reason we chose pub sub as a way of talking about this was that we're trying to convince application developers to move to this and understand what it would be like to use and make it easy from their point of view. So that's sort of why we chose that terminology a little bit, but I think these things are largely very similar when you get right down to them. So the quicker is, it's an early stage, some code that we're playing around with. I wouldn't say it was anything, every 6 months it's different. And it certainly was in a very early, highly motivated by Cisco's HICN, but also just trying to figure out what we need to do to simplify and make it easy to deploy, with the assumption that over time it would be, as we had a better understanding of what it was and what we needed, it would be replaced with more complicated things that were more aligned with the type of work being done in here. So we have name data. I'll talk a little bit about the names in a second. We think of it as publishing data with a given name, and we think of it as subscribing to partially wildcard groups of names. So let me dig into a little bit more detail about what this is. The data objects have a globally unique name, and we moved away from using the hash of the data to generate the name, and that's partially because of these wildcard features we want to do later. And also that we just didn't find that's, this idea of sort of self-authenticating data, it didn't turn out to be an amazingly useful property for us. We still needed to have a proper encryption authentication sort of technique on top of it anyway. So we moved away from that. Each object has time to live and some sort of priority that helps us in describing how to distribute them, particularly with congestion control. And also that, obviously data never changes, although that's, that was one of the things that we were sort of experimenting with this is it possible to get application developers to get their heads around writing applications where once they publish one of these objects with some data in it, they can never change that data again. They've got to create a new name and a new object, or let that object expire and delete. One of the other experiments we're doing was like, well, how big do these names need to be? And obviously you could do variable size or whatever other things, but what we want to do is, like, if we make a constraint, that really makes it easier to do high performance implementations on some of the relays and routing nodes that I'm going to talk about in a bit. And so our experiment was really, can we do it with only 128 bits? Can we take most of the applications that we care about and map them into a naming scheme that fits in that space? And so far, the answer to that has been yes. It's been a huge key part of it. First 24 bits sort of allocate the organization so we can get these global unique, and then you have the 96 bits inside of there. The applications use this pub sub. Now, when we subscribe to a name, we allow the low order in bits to be wildcarded, and you can say I'm subscribing to this range of names. And this is a little bit off of some of the traditional sort of approaches to this, but it's been talked about various ways of getting some type of functionality like this. And it makes it much easier for the application developers to get their heads around than the idea that they're going to send an interest packet for every single thing they want. Now, the underlying scheme might result in the same thing in the end. I don't really care. But from a model of getting application developers to think about, this was a much easier one to get them to think about. Right now, we're transferring all our data over quick. Partially this is driven by the fact that many enterprise firewall vendors or many enterprise firewall deployments we go to tell us that UDP is bad and quick is good. And that's the type of logic that's really hard to argue with. So we're just going with quick. I don't know what else. I can see Colin in the back of the room like, huh? Anyway. So we do like, I think one of the important things to us is the ability to actually lose packets. That makes it easier to do these high latency things, is that things can be lost at times. And data objects are end-to-end encrypted. We assume that there's a keying scheme that can deal with that out of band. So that allows us, the relays only have access to a limited set of metadata, mostly the name, in deciding how to forward this, and the times to live and things. No questions so far? Stop me here. You got questions on this? Okay. So the clients, we call our mesh net, the overlay router nodes or whatever that's distributing this data. We're calling them relays, whatever. That's just a name we've used for this. They're organized in some sort of mesh in the ways you would somewhat expect. And all of the ways that might happen, I don't really want to jump in too much. I want to talk about the incentives for deployment of these and who are the parties that we need these to deploy to make this work. So there's a couple different areas that we've been looking at in this. One is just putting them in Wi-Fi access points. And that's a pretty easy place to get them in. You're not talking about a super high performance type of environment. The access points are already doing that sort of level of processing and having a lot of coverage of that type of stuff. It's probably a small amount of code to put into those types of environments. And it allows you to get some distribution out near the very edge of the network. And whether it was in an AP or just was on some other on-premise device, that allows you a bunch of scalability. It also allows you to sort of recover separately from the latency and time lag that's happening over the Wi-Fi network and the type of errors you see there from the type of errors that you see across the WAN links. And in our experimenting with this, so we feel that type of having a mesh component on those access points or near very low latency in the home allows you to take a lot of the times where an application like WebEx delivers a really crappy audio video experience and split the types of errors it's seeing. It's separating the errors from the Wi-Fi and the errors from the WAN and allowing you to take different strategies for dealing with both of those. So there's a big appeal there to just improve the quality of those types of the end user experiences for gaming, audio, video conferencing. So the other place that I think is obviously really interesting to deploy these is at effectively the CDN type locations. And so let me just start at a very vague level with the sort of CDNs like where CDNs are deployed today, same sort of nodes. Most of the CDN vendors we talk to are interested in expanding to new applications that could use them, and you start talking about these large audio, video, or streaming applications. That's a really interesting market for them to go after, and this is leveraging something that's not very much different than what they're currently doing. It's easy for them to think about, fit into their business models, billing models, everything else. So it's appealing to that type of group. I think it's also appealing to carriers, particularly 5G type deployments and things like that, that are looking to expand into that CDN type market and have low latency nodes that are very close to the end users. And this gives a way to discover those, get on top of those, and deploy on them. So I think that's creating an interest in those groups to look at what's possible here and how this work might display. So I'm trying to think about this, I think as John Peterson would put it, we're trying to put food on everyone's plate, but to get something like this deployed, we need to make sure that this is taking some value to end users, improving the application. It's got development to application developers that they can cause their applications to scale out and distribute a lot of the complexity of their application out closer to the edge on compute infrastructure they're not necessarily directly running themselves. It's allowing the network provider and the next generation CDNs to offer a service that adds their value and one that the applications that would be possibly putting billions of minutes a day of audio video traffic onto these types of things. It's a reasonably sized market to go after, so it works there too. So we're trying to sort of put all those pieces together and try and get something for everyone such that this can be deployed. We're also obviously went with an overlay approach that everyone comes up with, in the sense that just makes it easier to incrementally deploy. Certainly have some desire to not have an overlay approach at some point, but can't really see the path to get there in the short term. So the current status, we'd love to be working with people on this code, and we're reaching out to anyone who's interested on this, both from a sort of classic research sort of point of view, or other people that are developing these types of applications, or might be one of the different sort of players that would help deploy this, whether it's Wi-Fi or end user endpoints or applications or CDNs. We're doing it all open source right now, and we clearly need to write up much better drafts. We're at a very early stage of just messing around with this stuff and seeing where it all is. We're driving a lot. I think this is a little bit different than what we're doing in Mock. Exactly, Mock is media over quick working group at IETF, and is trying to solve the narrower version of this problem with very concrete, workable applications. And we're trying to take a lot of these ideas and make sure that Mock's aligned with them, but we haven't tried. It's not like the Mock working group is going to do exactly quicker or anything. They're not going to. They're going to do something slightly different on that, but it might align well with these types of ideas. So very interested in working with people on that, and playing where this goes, and that's roughly the stage we're at. So with that is everything that I want to tell you about. What questions can I answer about stuff we're seeing, where we are, what's happening with the metaverse? I don't know. Ask me anything, not blockchain.
Great, thanks, Colin. So you have a couple of questions. Dirk Trossen.
Hi, Dirk. Colin, great talk. I like the deployment aspect of it, and we have something similar in the. I'm presenting on Friday the routing over service addresses work, and we put a similar use case into this. Particularly when you come from where could it be deployed, and who could provide the overlay. There's a lot of similarity with the thinking that we have in the ROSA overlays, and deploying those very far to the edge. It could be entirely deployed in homes only. The CDN provisioning is another aspect of it. One of our co-authors is very interested. He comes more from the Fediverse type of example. So why would you have content distributions at all through a CDN, right? And I think his angle comes also from, there's a lot of discussions in European countries, in particular in Germany, around doing media distribution for schools, for instance, right? Data localization. Why do I have to go through a centralized infrastructure in order to distribute educational material among 30 pupils in a small area? So I think there are a lot of similar thinking that would be really nice to sync, even though there are maybe differences in technical approaches. But that drive towards decentralizing and distributing the functionality, I think, is very common there. We stayed particularly away from thinking of how to put this into the underlay. Right. So the overlay thinking is key to that, and that's another similarity, despite the technical difference in how it's done. It would be great to have a chat about how these things may sync up. We also talk to CDN providers, CDN providers, carriers, and I said maybe this type of distributed Fediverse community could be an interesting one to get into this. the metaverse goes into that, but I didn't want to throw too much around. I find the Fediverse much more interesting. So the fact that you just set up a server at home as it works in Mastodon at the moment, I think it's very, very appealing for this type of beta distribution as well.
Yeah, no, I totally agree. And that, I didn't know about this work, so this is great. This was hoping to have happen coming out of this. And I also think that this type of thinking is happening in a bunch of different places in different ways, and it's all very similar, and we can help sort of bring that together and align it. I mean, you talked about the data. I didn't talk about sovereign SaaS at all, but it's one of the things that we've really been thinking a lot about. Is we get all kinds of customers, Germany wants to say, well, how can we keep our data in Germany? And I think that the general name data networking approach and being able to just take large blocks of names and say these must not be routed outside of this region in the network is such an easy approach to solve that problem. And I probably should have mentioned that. Like, I think that's another reason that is driving this. And we're seeing tons of that right now, of people trying to figure out I mean, right now WebEx has requests from 27 different countries to create something that's the equivalent of like a FedRAMP, unified in-country for government services only version of it. And it's really hard to figure out how to do that without some unified strategy like this. So I think it's a great use case.
I'm not a regulatory expert, but I think actually Europe has a number of legislations upcoming on data localization, which are really, really interesting and may really drive a lot of it. And for instance, from a school perspective, it's quite easy to understand why do I really need to put my data and in particular, as a pupil, as a teenager, as a child, you are under specific data protection laws, and most of the legislations. Putting that on a centralized engine is really not something that people appreciate. Thanks, will be great to catch up.
Thank you. Great points. Yeah.
Okay, very well. Richard Lee.
Hi, literally, and thanks for the presentation. And maybe I have missed something, but somehow I don't see connection here. On one hand, you have present AR, VR, even holograms there, then talk about the pops up that comes on quick there. And also we are in the ICN group here. So it seems to me that you have to tell us or convince us, right, why pops up is a good model or good solution to implement AR, VR, holograms, and also associated proof on problems you present to us, like something like that. So I have totally, I'm convinced. Sorry about that. And also here, I only can guess, although you didn't explicitly tell us, pops up here, maybe that interest data, like earlier, like even David Olen presents that if you are interested in something, that's the interest there, you just publish. So that's some connection to the ICR here. But I hope you can share more about that concept. Obviously, you have probably thought about that, but you didn't tell us. Thank you very much.
You're very right. I definitely didn't couple those together. So let me try and do a slightly better job of that. So it is the type of AR VR system that we're talking about here, of this multi-user AR VR system. You definitely probably could do that over a traditional RTP streaming type approach, no question about it. When we start talking about multiple users in it with multiple different types of data that they're putting into it, and the bandwidths are all going up and the latencies are going down, and that's really pushing the limits of what's easy to do over RTP. So I think that the techniques that having a pub-sub type approach makes it easier to do things like have multiple people contributing data that needs to be rendered in the same VR room, for lack of better space. It's same spatially VR, and there's multiple contributors putting data into it. That this might give you a better way of allowing that data to be distributed through the network quickly without streaming it all to one centralized server and then back down to the individuals. In fact, do I have maybe I just, can you, I have control of the slides. Yes. Let me go back to a slide here that I should have said a little bit more on. So with these larger amounts of data, with different endpoints having very variable amounts of data they can receive. So some endpoints that have a higher bandwidth might be able to get all the points in the point cloud, where some of the endpoints that have less bandwidth might have to only take, some statistical sampling of the cloud. This slide is looking for here too. We also have the issue of people who are topologically close, like in this case, Alice is publishing some data, but R1 and R2 can get a copy of that data quickly from the local relay, and they might have higher bandwidth of it. The data that's getting sent farther all the way over to relay B, so R3, R4 might get a slightly reduced set of the data because of what can be sent. Now, you could do all of this with ZIP, but I think it's easier to figure out when you have priorities for the data and naming of the data such that all the people who are contributing data into the 3D space I'm interested in, I can subscribe to that 3D space and get all of that data, and I can prioritize it easily in a way where I can say what I want. It becomes much easier to build these systems with this pub sub model. Not impossible to do them the other way, but that's the area where we see these really tying together, is because when we had a bunch of people sending data of different types that got filtered from a priority point of view in a different ways, it became really hard to do with a traditional system. I hope that is slightly more convincing. I can see from your face you're not 100% convinced, but
it's kind of easily give. So because I can easily list quite a few different and alternative, maybe competitive solutions. But I believe it's really hard to debate for or debate against. So obviously there are multiple things here, but since no matter what, like ICN is not the popular platform now, so
yes.
Many people still like traditional, as you even said, that RTP based, it's multimedia, like a new type of coding, and moreover, like it's not just end to end, but sometimes more interestingly, probably it's a multiple end communication, like a holographic concert or that kind of thing. Someone dance here, another one sings there, a third one even plays the band somewhere else while you compose them. So it's much more complicated. So right now your presentation has simplified and has hidden some essential problems we have never seen before for traditional video-based Zoom, WebEx, that kind of platform there. But anyway,
That's a good point.
Yeah, I'm glad you have presented this and shared your work with audience in this room. Thank you very much.
Thank you.
Okay, great. Hangshi?
Yeah, Han from Huawei. I think this quick work is really interesting, and I like this pub sub model. Yeah, and I think regarding to ICN, there is another aspect. It's about the content routing. For example, you have a relay mesh, and one relay receive the subset will be easier to forward to different relay. So which relay do you choose, and which path do you go to the original content to get the response? So how do you think about this problem?
So let me start. I didn't talk about that much because I think our solutions to that today are incredibly naive and probably not very interesting to the working group. But really, we're just keeping track. Right now, we have a small enough number of relays that it's fairly easy to sort of aggregate them up into, in a given geographic region, we aggregate them up to sort of a higher level relay. The higher level relays will full mesh connect for the subscriptions between everyone. So we'd have by higher level, at that level, I mean, we'd certainly different continents, probably different countries would be separate higher level relays. And then inside of that, we have the, sort of relays, lots of local, everywhere we would want to have a POP that was really close to users, a point of presence close to the users, have lots of relays that would sort of connect to the big distribution relays and also connect to each other just based on sort of the subscriptions they were getting and updating the routes from that. So it's a little bit motivated, I think, out of some of the thinking that came out of how WebEx distributed RTP media in general, which follows some of the models along those lines a little bit. but it's not particularly interesting. I think that there's tons of good research that could be done in that space if we had a good platform to work on that.
Okay, thank you.
I think I'm next in the queue. Is this on? Yes. So these are 4 questions which may wind up being all the same question. So maybe just wait till you hear all 4. Number 1, is this broker-based or direct name-based routing? Number 2, are the names entirely non-topological, or have you built topological levels into the hierarchy of the names? Is the amount of state in the relays order, number of subscriptions, number of publications, or something else?
Okay. As always, great questions from Dave. So
Is that all the same question? It may be.
I think, but was it 3 or?
Well, there are 4, but I
4,
think
okay.
they're all the same question.
So we don't embed any topology in the names at all in how we're doing it right now. The names would look more like we would fill the bits of the name by, some high level bits are like, this is the WebEx app, then, this is the conference number 1, 2, 3, 4 based on scheduling, and then there's some user in it, and then the different cameras and media that they contribute. No topology information or any information that's useful for routing in the names whatsoever. Different applications could do different things, but that's how we're doing it. And the relays don't look, when they decide how to forward or subscribe anything, they're not looking at the bits of the name to try and pull topology information out of the name. And the relays are keeping state that's order of the number of subscriptions they have. I guess, yeah. The order of number of subscriptions they have plus whatever routing information they'd made about connecting to other relays. But the bulk of the state in the relays is just simply the list of subscriptions when they've got an incoming packet, trying to decide if it goes out to one of the existing subscriptions or not.
So you'd better have pretty damn good authorization system so you can avoid Sybil attacks against the subscriptions.
Yes. So the thinking model around that is largely, I would say, sort of taking how we deal with CDNs today to a certain degree and thinking about that. That is that the application that was using this would have gotten authorization tokens, pass those out of bounds to the applications. The authorization tokens are handed along with with subscriptions, and also we have a parallel to a subscription, which is a publish intent, which is effectively a request to publish inside a given namespace. And both of those, the relays process slowly check the authorization tokens on, and then when they get the actual publish request, as long as they're in the name and on the same quick transaction that got the permission, that they can do it fairly quickly.
Thanks.
Yep.
Okay, Greg, one simple question. So you mentioned you're using Quick because, and you also wanted to be able to drop packets and so on. So what is the approach to congestion control in the system?
So we get one. So let me describe this at sort of 2 different layers. So first of all, let me say, like, this is an area where I don't know what we have works. Okay, definitely. Second, we're doing a couple different layers. The Quick layer itself, there's a Quick connection on any one of these connections over Quick, and we're getting whatever congestion control Quick provides us there as an upper bound on making sure we don't saturate the link or take something down. But overall, the application has to be also making sure that it's sort of bitrate allocation, overall way that it's working is suitable. So there's the congestion control that's happening in the link layer over the short term, but then there's the bitrate allocation and the rate control of that. And since we're thinking about so much media applications here, we're doing the usual thing of, like, if you're 5 megabit video stream doesn't work, we move down to a 2 megabit stream, that type of approach. And I don't know that type of model would work outside of media applications. So that's where it is.
Okay, thanks.
Yep.
Hi, Colin Perkins. I think you've identified one of the key differences with this type of application and the traditional video conferencing applications, which is that those applications are linear, and this is very much non-linear, and so needs a non-linear namespace. So whether PubSub is the right thing or not, the difference in naming, I think, is critical and explains why RTP doesn't work here. I was interested, the slide here has a sort of URL style name on it, and you mentioned 128-bit flat names. I was going to ask about the sort of why you were using a sort of a relatively unstructured name rather than something much richer.
Okay, so if I skipped describing any of this about this, and we haven't written a draft on this, but we plan to write a draft on this. It's really easy for application developers to think about a URL as a name of things. And if you look at most URLs for many of the common media service, and I'm talking about not the end one that you might put in the browser, but the names that are actually used for distributing the media inside of it, be WebRTC or something else, right? They often have this incredibly, there's effectively a couple of numeric identifiers of, a group and subgroup or whatever, and a frame inside of that. So we've been calling those numeric URIs with the idea that, and what this draft will be about, would be a way to take a numeric URI is a valid URI, it's a subset, but it has a schema behind it that maps it to 128 bits, that maps it directly to one of these integers. And you'd have to design, so what we're doing when we write these applications is one of the big discussions in figuring out whether we can take, WebEx and represent it into this space, or a chat app, or whatever it is. It's like, well, what will the naming schema look like? And we try and drive this naming schema and then show how it maps into 128 bits.
So conceptually, you have richer addresses, which you're then mapping down to something more efficient to forward.
It's a one-to-one by compression scheme that goes both directions, that goes between this 128-bit encoding and a text string that has logical data in it that makes it easier for a developer to look at it and think about it. But it's not a hash, it's not a compression, it's a one-to-one mapping using a schema-driven one-to-one mapping that just puts it into a form that's easy for people to think about.
Okay, makes sense. Thank you.
Yep.
And one more on the queue, Ueda-san.
I'm Kazuki Ueda, and the very exciting presentation. And I'd like to know the rate adaptation topics. And it seems that in the conversation with Dirk and you, and it seems that the data may be divided into some rate. And in this case, I think you may mention that we can put the relay functionality into the home Wi-Fi AP. In this case, Wi-Fi AP may have to subscribe many rates, or we may, let's say, create some technique to filter the required rate, only the required rate into the Wi-Fi AP or so. So please provide some your insight.
Sure. Okay, the great question, and love to. Let me use this picture on the screen here. Let's say that relay B there was running in a home access router, for example, of this conversation. So what we have today is the R3, R4 both subscribe to, if they both subscribe to the same rate, the relay B will effectively upstream towards the origin relay that one rate. It will aggregate subscriptions. But the relay B will only subscribe to rates that one of its clients subscribe to. So if R3 and R4 both subscribe to, let's say we have a high rate and a low rate of a video stream. If they both subscribe to the high rate, relay B will only subscribe to that high rate. Later, let's say R4 is it's farther away from the access point, its overall data rate's gone down, and it decides to drop its subscription down to the low rate. Now relay B will need to go and subscribe to the low rate at that time. It won't have already subscribed to it ahead of time. And we have talked about ideas of like, could you do something clever there to see that was about to happen? And then we just decided, no, that level of complexity in the relay is probably the wrong thing to do. So today, relays only subscribe to something that one of the clients below them subscribe to, but they will aggregate those subscriptions in sort of what data they're trying to receive. That's our current approach. Does that make sense?
Yeah. Yes, thank you.
Can I jump in here for just a second?
Oh, yeah.
Are the relays caching any data?
Yes.
All right, so then take me offline. I'll explain how what you just did causes congestion collapse.
Oh, damn.
Because we've seen it. Okay, with even in classic CDNs, where if
Right.
you are caching the higher rate, somebody trying to cache the lower rate can drive the uplink into congestion.
Yeah, we can talk. I can sort of imagine where this is going.
Yeah.
Yeah, it doesn't shock me we've done something like that. Let's just put it that way.
There are solutions to this, but it requires the relays to be smart and do extra subscriptions ahead of time to see if they fit on the link.
Right. Okay, well, I really appreciate time with everybody. Please get a hold of me. I'm easy to find. I'm Fluffy. And look forward to any input on things exactly like this. This will have made my trip to Japan worthwhile, just that comment from Dave. Thank you.
Yeah, thanks a lot for bringing this work to us. Super interesting and super relevant. So when we invited Colin, because we see a lot of this thinking going on in different groups at the moment. So this whole development of low latency multi-destination media distribution, it's, I think, super interesting and also super relevant for like this AR/VR application. You can also say metaverse if you like. And so I think there is lots of interesting potential for for discussions, future work, like leveraging some of the ICN concepts, technologies, but also for the ICN community. I think there's lots of value in really understanding what's going on in this space, and also looking at this work closer. So thanks again, Colin. And so in that sense, let's continue with some ICN work on media streaming. Cedric, are you ready to present? So Cedric is joining remotely.
Where is he? There he is.
Did I fix my technical issues right here?
Yes,
Okay.
hello, we can see you and we can hear you.
Wonderful. So let me see. The next step would be, can I share my screen? And open this.
Wait, we have to.
Okay, now I cannot see anything.
Okay.
What am I sharing?
It's coming up.
No, I didn't change my mind. So is there a way to, that's the window, this window. Share. Okay, how about if I do this? No, this well, I don't know.
Looking good.
Good. Just put it in slideshow mode.
Well, let's do that. Let's do full screen, whatever. I want to see you guys. Yeah. So the title of the talk was about video streaming, and I was the editor of a draft, and that was published as RFC 7933, which is one of the output of this research group. It's called Adaptive Video Streaming over ICN, and that considered like how to adapt video streaming for ICN. And actually, there's some a lot of what is the word? Well, the Fluffy's presentation ahead of this is related to that, to those idea of like, well, how can we do better streaming of it, or using ICN and this type of stuff. So the draft was about how you consider to adapt video streaming for ICN. What do you need to change on the video streaming side if you want to do some if you want to use ICN as your underlying network, and then how you can also use ICN to improve video streaming, and so there's been some work on that, and that's that draft compensated this. So basically, ICN was proposed as kind of a better architecture to deliver content, and so now the question is kind of like, what is the next step beyond this? So holographic type communication that was just presented is one of the good. It's a very, very good next step to look into it. And the metaverse is kind of the question I was interested in, and I'm going to talk about in this one. And it's a very high level, and there's no technical proposal in that. It's just kind of some ideas that I put together and see if there's an interest in that for this working group. So basically, what do I mean by metaverse? Well, you have some everybody has their own definition. I put 3 up there, and kind of the point is not to go over them, but the point is to say that everybody has their own definition. But some of them are. The first one is more like, you have some type of immersive environments, immersive ecosystem, and you can, and that's the one pushed forward by, the company formerly known as Facebook. And then so it's kind of an application where you can interact with others. The bottom one is kind of like, the next generation internet. It's like, well, this is kind of what replaces the internet for most of the interaction and most of in a way that is different from most interaction, be they like professional, social, or commercial, and it's kind of the word, the environment, the replacement for internet. So that kind of and those definitions have consequences on what the architecture underneath is, of course. So if you kind of try to narrow it down, you kind of try to draw up a taxonomy of what you mean by metaverse, and this is from a paper by Dwivedi and all about metaverse, and well, it's kind of adapted from, because it's not exactly from, but anyway, where you can define what type of environment. So you're going to have an immersive environment, and you can define, if that's going to be something realistic or unrealistic or something in between. And of course, with different constraint on the network that it has, going to have to transmit the data for that, if it's realistic, if it's real, if it's like, trying to recreate the previous situation type of the previous stock type of situation, where you have some room that you want to be immersed into at a different place, and then it's more than realistic, it's real, it's an existing place, and then you're going to have to transmit a lot of data for that. If it's unrealistic, well, maybe you can just transmit some Unity models and render them on site. So you have that kind of spectrum, and the interfaces as well are different type of also yield some type of axis and of dimensions, where you're going to have, well, some type of immersive thing, sometime where you're going to view on a head-mounted display, and the screen is going to be really small. Something where you're going to be, you're going to have holographs or something where there's a lot of data. All kind of again, range of dimension for this, then type of interaction that you're going to have, and also the type of kind of, like circuit and pricing you want to achieve. So, and of course, for all like different instantiations of those, kind of virtual worlds with those different properties, you're going to have different requirements that come from this. So kind of like defining some type of taxonomy and requirements could be one objective. Anyway, and one of the things which is important, I think, is the dimension of how much centralized you want to do this and how distributed you want this to be. So if you look at here, the kind of, this is the ecosystem. That's a slide from that's been around. I think this is from some guy has a startup for gaming platforms or something. I don't know who John Rudolph is, but anyway, this is kind of the all the companies that could be linked to it. Actually, it's not an exhaustive list, of course, but in terms of where we're at, so I want to highlight the infrastructure side of things, which is where kind of most of the work that we would have to consider would be there. And of course, you're going to have to support this infrastructure. Is going to have to support all the layers on top of that. But so kind of like we can narrow it onto where we want to focus the work in terms of, at least we focus on these slides. So and actually one of the company that's not there, and I just put it there as a little wink or whatever. It's just like Apple is supposed to unveil something in a few months. So, and again, the question is, how is it going to be? What type of so is it a device, or is it like a device plus an ecosystem, an environment? It's like the iPhone with the App Store. Or is it something that is something that runs on a different platform, or is it a walled garden? Is it open? So all these dimensions coming into play when you want to try to figure out, how to relate ICN with metaverse. Anyway, so I started from this RFC earlier, 9733, in terms of what is the video streaming and how do you expand this, and I view kind of that you have, and it's not a Venn diagram, it's just like, my illustration, PowerPoint illustration skills limits are there, but basically that you want to have some kind of, like, you have this set of existing applications that kind of like, that you want to inherit into, like, if you, so the draft I was talking about video streaming was kind of like, and which is kind of the center of this talk is going to be the one of the things that you want to inherit into, like, going into the metaverse, because you're going to have to stream some stuff. But video conferencing is, another example of so it's kind of the applications that you want to have, where you have this collaborative environment, and so you get this, that you want to bring this, and whatever you learn. So I know, like, there's a lot of work on video conferencing, in particular from UCLA. We did some with here when we were at Huawei with Ravi on video conferencing as well. I mean, there's some a lot of interaction. There's a lot of legacy work in terms of ICN and video conferencing that would have to be brought in there. Social networks as well is one of the other thing you want to bring in. And this is not exhaustive, of course. It's not like you have to take all of this into account, but include a lot of other stuff. So if I go back to now that video streaming document, what were the issues we're looking at? And so if this is kind of the an excerpt from the table of content from that RFC, and those are kind of the most of the section and the subsections in this document. I didn't keep the numbering. But so what do you want to do with that? Well, you had some video streaming that would have to stream some time of like virtual environment views somewhere. And again, with the how are those rendered? Are they streamed, or are they created into the display? I mean, this is kind of, it's a lot of question marks. But so you're going to have some type of discussion on the encodings, and this is actually goes back to the previous talk again, where you have to have this encoding of or at least this sharing of huge amount of data to recreate some holograph of somebody. So what are the encodings for that? And then, so you have the in the RFC, you have those interactions of video streaming with SCN. How do they interact together? Well, similar with the metaverse, you're going to have the same issues in terms of what kind of mechanism you're going to have for what the request response mechanism to get the data, the caching, or all this. Those are issues that are associated with ICN. How do they play in that? The integration of video streaming and ICN in the draft goes into a similar integration question. The draft has a chapter, a section on peer-to-peer video distribution, which also might be relevant there in terms of, well, do you want to distribute content? You have those tools. Do you want them to be centralized, distributed? You want to have to go to peers to get the, to have a session directly between two people that are participating in the same thing. And so there's some potential for leveraging those ideas. So there was a section in the draft on IPTV and ICN, which maps to some type of multicast and the multipath, mostly multicast in the metaverse application. And then the digital right management in the draft also maps to a lot of, and I think when I envision a virtual, immersive, collaborative environment, there's a lot of objects that have rights associated with them and who own them, and you have different layers. And I put a slide on this later for some discussion of this. So the question is metaverse and ICN. So from the infrastructure perspective, the metaverse is kind of a distributed system that shares content in real time on a massive global scale with some requirements, rather stringent quality of experience requirements for the users that has to do that in a secure way with rather complex ownership and access privileges. So that seems to me actually like stuff that ICN has been looking at for many years, and actually not just to me. I think there's there are a lot of people working on this already. I just saw a proposal from Dirk actually, like the microverse proposal. So I mean, there's a lot of stuff, but and the question is, well, so can we? At a philosophical level, there are some similarities. There are some synergies. But can we adapt ICN for the metaverse? Can we adapt the metaverse for the ICN? Can we do this type of thing? So those are the questions that I think are interest to this group. So I now have a couple slides on potential. I wouldn't call them research directions, but some thoughts and that I put in there. But the kind of that where there is some work that needs to be done, because, well, you inherit some stuff that exists that works, but that's not enough, right? It's not. This is not an engineering issue. It's not a matter of like taking those. Oh, you have those streaming proposal, you have those video conferencing proposal, you have this kind of stuff. You can put it together. You have to do more than that, So the objects in the in that sense was something that I think is ripe for more work, because you have the data objects, right? And ICN knows how to distribute that. That's fine, but then those data objects represent actual objects into a virtual world. So they're objects, they're avatars, they're stuff that are there. And now you have to discuss, well, what do I do with those objects? How do I define them? How do I construct them? And how do I manage the rights to access to that? So if you want to access a piece of content in a streaming framework, well, you have to have the kind of the permission to see it. But it's a contract between you and the provider of the streaming content. But in that case, you have a lot more intricacies, in the sense that you have you have different people that are unable to access content in an environment that is you have to be also allowed to access in that sense. And then some of who has the right to see an object, who has the right to use it, to modify, to remove, to do anything with that. So I was actually looking forward to Mark's presentation earlier to see, well, how do you define a set of objects that are associated with some specific application, or some specific space within a metaverse application, because that's where I think that would be an application for Flake to be expanded in some sense. So what type of manifest you have that's going to be able to describe the relationship between different objects. So the ownership as well is kind of something that is, I think, has some interesting implication in terms of designing the right naming structures and the right security and authentication processes on top of that. because you have a platform that has to have access to those environment. Then you have the users, and then you have, one of the things I was thinking is like, if you create something in that environment, who does it belong to? Who is who like if you make a performance in such an environment, who has the right to that, and how do you get that formalized into the protocols underneath? So anyway, so one of the topic I was interested in is how to get this decentralized. And I don't want to, one direction I specifically have no interest into is the type of blockchain distributed ledger type of stuff. But maybe some people do have interest for that. I mean, at least in the metaverse context, a lot of people do. But so how do you centralize versus decentralize? Some of the if you do like an app which is centralized, run by a mega corporation, and that provided as a service, as an overlay, that's one way of doing this. If you do it as an embedded something within a network, that's another way, which of course I think that the latter is more in line with the work of this group. So you have to have some type of hierarchical structure, of course, because you're talking about something which has to massively scale. The question is what type of relationship do you have between the different distributed servers? Can you run if you're disconnected from any central authority? So ICN is good at that in the sense that it decouples the object from the origin server. It's like you publish your thing, you sign it, and then you can send it to the world, and you can be hosted anywhere and found anywhere, and that's fine. So that's kind of a step towards decentralization. But now you have much more than that you want to send out in the world. It's much more than just like a movie. It's kind of like something that has to run in a decentralized manner, and is the so for instance, if you want to operate on those contents because you have to perform some operation on it, can you do that using, for instance, the name function networking, or those type of ideas? Anyway, so interoperability is another topic. This is another slide from John Radoff, which shows the kind of where you have to what interoperability means. For us, of course, it's kind of just the connectivity communication. I mean, my thought is, and maybe somebody's going to say no, but anyway, it's at least we have to restrict ourselves to having a common framework at the connected level, but I guess I'm contradicting myself in the sense that some of the rules, in terms of persistence of presentation or access and this type of stuff, have to go across different layers as well. So anyway, so this is kind of the research challenge that I do see for a metaverse application in ICN. So interoperability, I talked about this, scalability, of course, and this this is something that we always talk about in ICN, so that's good. Privacy, security, low latency. So this is not really to ICN, but of course, if you're gonna have to have some interaction, social interaction, or some real life, I don't know, like some sports event or something, whatever, some stuff that requires low latency, then you have to, and that's not an architectural question. It's kind of it's the physics question. How can you bring things like faster with higher? So there is at the protocol level the thing of providing better quality of service, but there's also like at the physical level, how do you speed up the network? And so there's this interesting project which is not related to ICN at all, but I thought interesting was the networking and the speed of light. But later on today, which is I think it's still today for us, maybe tomorrow morning, but in the night there's a side meeting on a satellite network, low Earth orbit satellite networks. and that side meaning is relevant in the sense that for some communication, especially intercontinental communication, a satellite constellation is faster than fiber. So you would reduce the latency on that. So I would encourage you to attend that side meeting if you're interested. Then, of course, the machine learning is there. In some of the work I did on streaming, and actually, Colin just mentioned this earlier, which is as long as if you move your point of view with respect to a hologram or with respect to a field of view in a 360 video streaming, then you're going to have a communication with the server to get the new data to you, and so this has some type of in 360 video streaming, immersive video streaming. The work we did was focusing on how predictable is this? How far ahead can you predict the behavior of a user? And some of it is dependent on the video itself, and some of it is dependent on the user, and some of it is depending on the sound, and some of it. I mean, there are some dimensions where you can predict some of the behavior of the user, and you can also use some type of, you can learn the behavior of your user in those type of contexts. So how those lessons from the video streaming apply to the metaverse?
Cedric, sorry.
Yeah.
We would have to ask you to wrap up fairly soon. We have two other presentations.
I think this is my last slide.
Okay.
Actually, is okay. Let me make it my last slide. So anyway, the research issue metaverse through programmability, high precision of the traffic. How are you going to deliver traffic that has a stringent latency? So how do you evaluate some proposal? What are the models needed to evaluate the research in the sense that how do you simulate this? Because you cannot build it, and I mean you can build some things, but how do you how do you simulate this is another question. Like sustainability and green networking, those are issues, of course. And what am I doing? Because I'm trying to get to the next slide. Okay, so I'm gonna skip this slide, go to the conclusion slide, but basically, kind of what are the ICN research challenges for the metaverse here? It's kind of for the group here to define and solve, but one of the question is it worth exploring some type of document similar to RFC 7933, but for this type of application? Can we expand this, or is there enough material in there? So I started to draft something. I did not make it to the cutoff, but if that's something people are interested, I will send it later. And that's my last slide. If anybody has a question, let me know.
Thanks, Cedric. That sounds great. To have some say text to read and to discuss further. Any questions? Okay, I think people are waiting for your text to read. Thank you very much.
Okay, thank you. Take care, guys.
Okay, good to see you. And so we're moving on, and we have Mark Moscow online now, and so we're now doing the Flick presentation, so something that Cedric also mentioned. So a specific technology also relevant in this context. Mark, do you want to try sharing your screen?
Hi there. Okay, yeah, let me try sharing that. How's my audio?
It's good.
Okay. My screen sharing, my presentation mode is going to take up both screens with this, so I won't see the raised hands or those sorts of things.
Okay. So okay. Yeah, it's coming up.
And window. How about?
Okay, you are good to go.
Okay, that's coming through. All right, so this will be a discussion about the Flick manifests, and I'm going to go over a few use cases about how one would use the draft. So there'll be a really quick intro about what Flick is to try to catch people up, and then we'll talk about the minimum requirements for using Flick, and then a few examples, and these examples are going to focus on the NDN use case, since there's some interest from the NDN people about trying to use this in a current project. All right. So Flick provides a manifest of hashes, so you can retrieve content objects or data objects using the hash-based name. And the manifest will be split between multiple of its own data objects because the manifest is too big. So there's a way to retrieve manifests, and there's a way to retrieve application data based on these hash-based names. There's a canonical traversal order, and if you follow that order, all the bytes will reassemble into the correct sequence, so you get the original object back. Some cases you might want to skip around. You might want to skip around because you're just interested in getting to a next iframe, or you might skip around because it might be faster to retrieve the object in the non-canonical traversal order, even if you're going to reassemble it that way. And what else is there? So there is an encryption scheme for Flick that I'm not going to talk about. And there is this topic, there's this idea of name constructors in Flick. So a name constructor tells the Flick processor how to generate an interest name. So, what's the prefix, what's the sequence number, what's the hash name, so what's a routing locator. So the name constructor embodies this idea of how to construct an interest name from a manifest entry. So the simplest Flick manifest is an unencrypted manifest where it's wrapped in an NDN or a CCN data object. And the node TLV is the first TLV that you would run into from Flick. And then a hash group is a set of related hash pointers. So basically, these would all just be like your your SHA-256 hashes that you would use to assemble the name. So in NDN, they have a content type of 1024 that's already reserved for Flick. So that would be the content type in NDN. The hash type would be the NDN implicit SHA-256 digest component. And then you would have pointers that are, an integer number of the pointer TLV and hash TLV. The downside of this is you haven't specified how to construct interest names, so it's using the default name constructor, which is probably not appropriate for NDN because it uses pure hash-based naming. And you don't have any ways of doing segmented names and so forth. So we'll add a little bit more functionality into this to make it more practical for NDN. So, NDN prefers that every data object have a unique name, not including the implicit hash. So they use a segment number naming. So Flick has a name constructor for segmented names. So it uses a common prefix, a segment number, then the hash, and the issue with using the segment number naming is the manifest processor, the Flick processor, has to keep incrementing the segment number, and it has to do this using the canonical traversal order because that's how the sequence numbers go, or the segment numbers. Another thing is if the manifest has one prefix, it has its own name, and the application data has a different name, then you're tracking two segment numbers, one segment number for the manifest segments and one segment number for the application data. So how this looks is in Flick, we would define some node data. So there's an NCDEF, a name constructor definition. So we would redefine the default 0 to be a segmented schema, and there would be a locator name, and this is basically just a name prefix that would be used for that NCID of 0. And then we would define another name constructor of NCID 1, and we would use this for the application data. You know, the 0 and the 1 for the sub manifest and the application data, that's all arbitrary. Those could have been any numbers. Name constructor definitions are inherited, so you only need to define these once, you know, like at the root of your manifest, and they'll apply to to that manifest node and every node under it in the manifest tree. If there's any questions, like I said, I can't see the hand raising thing, so just let me know.
Okay.
You are allowed to redefine name constructors further down in the manifest tree, and there's some specific use cases about why this is useful. It should not cause much difficulty in the manifest processor because it only affects the current node and those below it, and since you can't retrieve the nodes below it before you retrieve the current node because you don't know the hashes, you know, it shouldn't be that big of a deal as long as you are able to track a name constructor per manifest branch. So using these name constructors in a manifest, we now have two hash groups. The first hash group is pointing to other manifests. So this will use name constructor ID 0. And the second hash group points to application data. So this uses name constructor ID 1. So this is telling the Flick processor for the first hash group, use the first name prefix and the first set of segment numbers, and in the second hash group use the second name prefix, and it'll have its own set of segment numbers. So if you want to be able to retrieve data out of order, you need a way of including the segment number with the hash pointers. So it's all explicit for the parser. You don't have to accumulate the segment numbers over the traversal order. So the way Flick04 does this is it has a different entry under a hash group called an annotated pointer. And an annotated pointer allows you to put metadata like the segment ID annotation TLV. So every hash entry has its own sequence number, so you could list them in any order you want because it's all explicit. This gets very verbose because you're adding, a TLV and a segment number for every hash pointer. So as I was putting the slides together, I realized, it might be easier if we just say, here's the starting segment number for this hash group, and then you increment it. So we'll probably add this to the draft because it's a much more efficient way of doing explicit segment numbers in the manifest. But with this mechanism, you can retrieve in any order you want. Routing hints. So these are used, in both NDN and CCNX, and they basically say, here is a topological name to use to get the actual name that you want in the interest or the data object. in Flick04, we call these locators, and that's the same word that we used for those prefix names for the segmented interest. And we should just change the names so we don't call two different things locators, but whoops, we'll fix that. So the routing hint locators are located under the node data. So this is the same place where we did our name constructor definitions. So you can provide one or more routing hints, and they're not used in any particular order. The manifest processor could pick any one or use all, or whatever combination it wants. Yeah, and I believe that these are inherit. I don't remember if these are inherited also. I'll need to check that. I know that the name constructors are inherited through the manifest tree. I don't remember if the routing hints are inherited also. If you want multiple routing hints, you can't do that all in one manifest object. So for example, if you want one set of routing hints for sub-manifest and one set of routing hints for application data, then you need to organize your tree so you only have one type of thing in each manifest object. So you would have a tree, for example, where the root manifest just points to sub-manifests, and then sub-manifests only point to other sub-manifests or to application data. You don't mix it. This way, each of these data objects has the correct set of locators in it for retrieving the data. Perhaps we need to restructure this, based on usage. So if this is a common thing to have different routing hits for the manifest and the application data, we might want to organize it more like the name constructors, where you can you can intermix them more easily. So I didn't talk about encryption. I didn't talk about some of the other metadata like subtree sizes and things like that. I didn't talk about all of the naming schemas. So we have naming schemas like prefix name and interest-derived name and data-derived name. I only talked about the segmented name schema, since that's really what you would use for NDN. I didn't talk about protocol flags. There's also a way of telling the Flick processor to include certain protocol flags, like must be fresh, or other things that you might put in an interest. So there's a way of including those in the manifest also. Okay, so that was it. Please ask questions or.
Yeah, great. Thanks a lot, Mark, for doing this work and for presenting. I don't see any question at the moment, and given the timing, I suggest that we do the questions on the mailing list.
Okay.
That's okay.
Yeah, I'd be very happy if you're thinking about using Flick and you have questions. Let me know, or if you have changes or edits, please send those to me. Thank you.
Yeah, thanks again. That's really great work. Okay, moving on. Ueda-san. Loss detection for ICN, and slides are coming.
Okay.
Yeah.
Yes. Hi, I'm Kazakido from KD Research. Today I will present my talk about the loss detection, and I introduce some idea of the pro-based approach. And this is the short agenda. And as a brief, I briefly introduce the loss detection and recovery in ICN. And in general, there are two approaches. First one is the loss detection and recovery executed below the ICN layer. that is implemented in the link layer protocol or the forwarding strategy. And the second approach is the end-host-based approach, and that is executed above the ICN layer, and that is implemented as a feature of the ICN socket. And the
Doesn't work.
Did I just screw you up?
Maybe. I lost my.
Sorry.
I got kicked out of the meeting. Sorry. Just a moment. Okay.
okay. Oh, okay. Thank you. And as for the network side, there's one aspect of the implementing as a forwarding strategy, and this is good for the rapid reaction for the path failure, but it may introduce some complex interaction between the application demand and the strategy's behavior. And the second approach may be the phase or link layer protocol that detects the packet loss between the two ICN routers using some internal sequence number. And this approach is very nice and simple mechanism and achieves the fast recovery. And this feature is implemented as in hybrid ICN, WLDR is implemented, and in NDN, NDN-LP is implemented as for these features. But when in the past project, I executed some demonstration that is 360 video streaming over the ICN testbed. And I enable the NDN-LP, but I encountered some lost data. So the in-network loss detection and recovery can provide a lossless communication for ICN, but if the application is overloaded, it may introduce the packet loss, and also all hops should enable this feature unless we cannot rely on this lossless communication. So from this point, I focus on the loss detection as the end host as a backup plan. But many schemes uses timer-based loss detection for in this research area, and the resonance image timer is calculated from the recent RTTs. That is very similar to the TCP/IP. And actually, the NDN cat chunks, that is the default tool of the downloading tool of the NDN, which uses the time-based loss detection. But there is one problem, that is a splice timeout. Splice timeout is a known issue of the TCP/IP. That is a false loss detection in the timer-based algorithms. In the timer-based algorithms, when the RTTO packets exceeds the RTO, that packet is considered as lost, but the packet can be delayed from various reasons, including the retransmission of the wireless link or the queuing delay. And also, the problem is that NDN may introduce splice timeout more frequently than the current internet, because in NDN there are many source nodes, and the RTTO packet is not constant compared to the current TCP/IP. And this is a brief example. When let's say when the cache stores first in data packets and the rest of the data is stored as a remote producer. In this case, after the elapse of the closer RTT, depending on the RTO, it may expire and the consumer detects the packet loss. That is the splice timeout. Okay. And in order to overcome this issue, PCON, that is used in the Indian cat chunk, tries to overcome this issue by setting the large minimum RTO value, let's say the 1 second or so, to avoid the splice timeout. But this can avoid the splice timeout, but it may introduce a long loss response delay. And also this parameter, optimal parameter of this mean RTO is highly dependent on the topology, and we cannot know this value a priori. And from this point, I'd like to design some alternative to such approach. And I think that the problem is retransmission timer alone is not so suitable for the ICN communication model. And our idea is we try to obtain and update the RTT of the new pass and use it to determine the actual packet loss. And our idea is ending probe timeout, which uses a probe interest to get the information of the current pass information. This is a behavior of our scheme. And after elapse of the T1, previous schemes considered it as lost, but we try to discover the current path using the probe interest. And the probe interest is this is a very simple behavior, but it requests next data, and that may be satisfied from the new source node, remote producer. And after receiving the response, we update the loss detection timer and use it to check the actual timeout. And the detailed design is as follows. And we use core component of our scheme is 2 timers and the probe interest. We use the 2 timers. First one is a probe timeout, and the second one is a loss detection timer. Probe timeout is a very short timer calculated from the recent RTTs, and it triggers the probe. And on the contrary, loss detection timer is calculated from the highest RTT seen in recent packets and determines the actual packet losses. And the third component is a probe interest. This is a single interest which requests the next data. And we assume that the next data may be follows the similar path of the current infrared data. And it is used to obtain the latest RTT and the update LDT with this return value. And I think currently I use the normal interest packet as a probe interest, but I think that the CCN info or the ICN ping may be the good alternative to retrieve the path information. And I did some simple evaluation using the Indian SIM, and we compare the Indian PTO and the PCON with 4 mean RTO settings. And this is a simulation scenario, and this mimics the example I explained before. The half of content is stored from the close-up producer, and the rest of the data maybe is stored as a remote producer. And this shows a good put of this scenario, and this shows and the performance of the PCON is depicted as a dashed line, and we can see that the good put is depend on the mean RTO parameter in PCON, because depending on the mean RTO, it suffers from the splice timeout. And in this case, when we configure the 200 millisecond, PCON achieves a nice good put because it can avoid splice timeout. And the NDM PTO, our scheme can achieve the comparable good put for the optimal PCON. That is, difference is within the 6%. And we can achieve this good put without configuring the topology-dependent parameters. And as for the overhead, when we configure the low mean RTO value, Peacon suffers from the spurious timeout. And on the contrary, our scheme achieves a very low space timeout. And also as for the delay, when we use Peacon with high mean RTO value, it shows the long outliers due to its long loss response delay. And our scheme can achieve the almost equivalent to the Peacon. Okay, this is conclusion. And we focus on the end host based approach and use some pro-based we propose some pro-based approach to get the path information and use it to detect actual packet loss. As a next step, I will evaluate the performance with our actual testbed. Okay, thank you.
Great, thanks. We have time for one question. Okay, then we're looking forward to future results from your experimentation.
Okay, thank you.
Thanks a lot. And just quickly, almost done. Just a couple of announcements before we finish. There's a new project that we just started with UCLA and HKUST called Name Data Microverse that got awarded some funding by Omidyar Network in their Future of Data Challenge. So check out namedata.net/microverse if you're interested in that. Furthermore, we have the upcoming IEEE Metacom workshop on decentralized data-oriented networking for the metaverse, DORM. So there's a deadline that is coming soon. Be great if you have some work in this space, if you want to submit that. I think it's a good opportunity. And then furthermore, there's, of course, the ICN conference this year. It's going to be in Iceland, Reykjavik. So that's also waiting for your submissions. Call for papers has been published. And then for today, there is actually a side meeting about trust-enhanced networking. So colleagues from Fujitsu asked us to share this information. So if you're interested, go to G301 at 5 p.m. And then that brings us to the end of the session. Thanks a lot for being here. And thanks again to all the presenters. See you soon. Bye-bye.
You know, we always start out with thinking, oh my God, how we want to an agenda, and then we all. I'm sorry about your kick the towel back. I just didn't want this to be done. Sure. No, that went pretty well, I guess. No, good. Lots of people on it. I don't know if they're all tourists, but. Huh?